Imagine a future where the United States no longer relies on China for the batteries powering its electric vehicles. What if a new breakthrough, hidden behind the pristine walls of an American research lab, could finally tip the balance of a global technological rivalry? The answer may be brewing right now in the secretive corridors just north of Detroit. Inside General Motors' Global Technical Center, the atmosphere feels more like a high-tech medical lab than a traditional car factory. Spotless white corridors, dazzling with LED light, led to sealed rooms where scientists don full body suits. Here, they are not just tinkering with engines, they are reimagining what will power the cars and trucks of tomorrow, a new generation of lithium manganese-rich, or LMR, batteries. Down the road at Ford's Ion Park, another team is racing to crack the code. Ford's researchers have spent the past 4 years experimenting with these LMR batteries, finally reaching pilot production in Michigan. What is at stake is not just a new type of battery, but a shot at rewriting the global rules of the electric vehicle industry. To understand why this is such a high-stakes moment, consider the current power structure of the EV world. China holds an overwhelming grip on the battery industry. According to the International Energy Agency, roughly 85% of global battery cell production now happens in China. Even more, about 65% of the world's nickel refining and a staggering 75% of cobalt refining are dominated by Chinese firms. These are not small advantages. They are the result of decades of aggressive investment, industrial strategy, and control over critical raw materials. As one former CTO of CATL put it, unquestionably, the Chinese are ahead in manufacturing technology. For American automakers, this is a critical problem. Batteries are not just the heart of an EV. They are its most expensive and strategically vulnerable component. Most lithium iron phosphate batteries, which are cheaper and increasingly popular, are also made in China. As a result, owning the next leap in battery technology could mean the difference between thriving and falling behind in a new economic era. That's why GM and Ford are now betting on LMR batteries, a chemistry tweak that could change the game. Traditional batteries like nickel, manganese, cobalt depend on costly and geopolitically complicated metals. LMR batteries, by contrast, use more manganese, a metal that is abundant, easier to extract, and much less expensive. As Sam Abwel-Samid, a leading battery analyst at Telemetry, notes, using more manganese can make it easier to find alternative battery supplies. But the story is not just about supply chains. LMR batteries could offer up to 1/3 more energy density than current lithium iron phosphate cells, all without breaking the bank. As Bloomberg Nef's Evelina Stoicu says, GM's new battery recipe is exciting and should translate to longer range. With the U.S. government pouring billions into battery research and the Inflation Reduction Act incentivizing domestic production, the pieces seem to be falling into place. Yet, there's a catch. LMR batteries have historically struggled with problems like capacity fade and voltage degradation, issues that could limit their performance in real-world conditions. Both Ford and GM claim to have made significant breakthroughs. Ford, for instance, has already begun pilot manufacturing of its second-generation LMR cells, signaling a bold commitment to this new technology. But will these new American batteries truly be able to break China's chokehold on the industry? Or will technical hurdles and global supply realities keep the U.S. playing catch-up? The next chapter in this technological contest might decide not only the future of electric vehicles, but the shape of global economic power itself. So what happens if GM and Ford truly crack the code on LMR batteries? The consequences could be enormous, not just for Detroit, but for the entire global auto industry. There's a real chance that for the first time in decades, American battery technology could leap ahead and set a new standard. As Charles Poon, Ford's director of battery innovation, boldly put it, LMR is going to be the LFP of the Western Hemisphere. One future path is a U.S. technological renaissance. Imagine a world where American automakers supply their own high-performance, affordable batteries, breaking the cycle of dependence on China's supply chains. This could mean more electric vehicles built in America, more jobs, and a stronger position for the U.S. in the clean energy economy. Kurt Kelty, GM's vice president for battery strategy, calls LMR a game-changing battery for electric trucks, setting a new bar for performance. If this vision materializes, U.S.-built EVs could finally compete on price and range with their Chinese rivals, turning the tide in a fiercely competitive global market. But there's a flip side. The technical hurdles are still very real. LMR batteries have long struggled with issues like voltage fade and limited cycle life. While Ford's pilot lines and GM's secretive labs are making breakthroughs, scaling up to mass production won't be easy. China still controls about 3/4 of the world's battery manufacturing capacity and more than 80% of the critical minerals needed for most batteries. Bob Gallion, former CTO of Chinese battery giant CATL, put it bluntly. Unquestionably, the Chinese are ahead in manufacturing technology. If the US can't move fast enough, or if the chemistry proves less robust in the real world, China could extend its lead rather than lose it. And then there are risks of a new kind of arms race. As both sides pour money and talent into battery innovation, the next big leap, maybe solid-state batteries or even sodium-ion cells, could make today's breakthroughs obsolete. Will the US double down on advanced research or lose focus after the first round of LMR launches? Funding priorities matter. Over 90% of US federal battery support has gone to lithium-ion, with less than 1% for true next-generation tech. So, what does all this mean for you, the everyday driver, investor, or tech enthusiast? First, it means electric vehicles may soon become more affordable and practical. If GM and Ford succeed, we could see American-built EVs with longer range and lower price tags within the next few years. More choice, better technology, maybe even electric trucks that can tow, haul, and road trip across the country, all powered by locally sourced manganese. For everyone watching global markets or the tech sector, this story is a masterclass in how economics, geopolitics, and raw science collide. The US push for battery independence isn't just about cars. It's about energy security, job creation, and who leads in the technologies of tomorrow. If you're invested in auto stocks, battery supply chains, or the future of green energy, keep a close eye on these pilot lines in Michigan. Winners in the battery wars could dominate global markets for decades. And if you're looking for a practical lesson, don't underestimate the power of chemistry and the value of thinking a few moves ahead. As Tim Urquhart of S&P Global Mobility warned, the US and European auto industries need no more warning about the competitive threat from China. So, can American innovation in LMR batteries truly overcome technological and geopolitical obstacles to reshape the global EV industry? The answer, for now, is a cautious yes. The breakthroughs in Michigan labs are real, and they show that with the right focus and investment, the US can challenge, even upend, China's battery dominance. But the outcome depends on sustained commitment and a willingness to keep pushing the technology envelope. Here's a secret. While everyone talks about lithium or nickel, manganese often flies under the radar, yet it could become the single most important mineral in the next chapter of the EV revolution. Its abundance and diversity make it the geopolitical ace America might need. The race is on, and the finish line keeps moving, but history shows that bold bets on technology can change the world. If you found this deep dive helpful, make sure to subscribe and hit the bell for more stories at the intersection of technology, economics, and geopolitics. What battery breakthrough do you think will shape the next decade? Let us know in the comments below. Until next time,